Today, I'm going to go over graphing and key features. We're just going to finish that up. This is graphing day 2. You can just continue this right on your notes that you started in the last meet. We're going to go over the step function today. So I'm going to change this display. So both of these examples are what we call the step function, because they look like the stairs, right? So in this first example, and actually we can look at one at a time. So if we look at the first example, it looks like a set of stairs, right? If I was to connect these, it kind of looks like a stair. It's sort of how it gets its name is it looks like steps. So this is the step function. So this is a function defined by 4 other functions. So it says f of x equals 0. That is function number 1. So function number 1 starts at the origin and goes all the way up to, this is an x of value of 1. So this is 1, and it has an open circle there. So this is the first function. The second function is f of x equals 1. So this starts at 1, it has a closed circle at 1, and it goes all the way to 4 and has an open circle there. So that's the second function. The third function, f of x equals 2. So if I go to my graph, f of x equals 2. So closed function at 2, or sorry, closed circle here at 4. And I'm going to go all the way and stop here. This would be 9 on the x. So open circle at 9. And then the last part of the function is f of x equals 3. So this is function part number 4. I guess I should label these. So this is 2, this is 3, and this one is 4. So I have a closed circle at 9, and then a line, and then it goes up to 10 and stops. So for this first one, I want us to find the domain of each of these pieces. So remember, domain is how far right and how far left your function goes. So in this example, the blue is the first function, so let's start there. So f of x equals 0. So the farthest left it goes is 0 because it starts at the origin, so 0, and it ends at 1. So 0, comma 1. Now remember that 0 was a closed circle, so I'm going to put a bracket, and the 1 was an open circle, so I put a parenthesis. So that's function number 1. That's the domain of that first function. For function number 2, the second function starts at x equals 1. It's a closed circle, so I'm going to put 1 in a bracket. And then it just continues on and stops at 4. So up to 4, and there's an open circle at 4. So that's the second function. And then to go from the second function to the third function, I just go up, and I have a closed circle this time at 4. So I'm going to put a bracket and a 4. And function 3 goes all the way up to 9 and stops. And there's an open circle at 9. So this is 4, comma 9. And I'm going to put a parenthesis because it's an open circle. And then to go from function 3 to 4, I jump up and I put a closed circle at 9. So I'm going to have a bracket at 9. And I go up to 10 and I stop and I have a closed circle at 10. So it's going to be a bracket. So this is the domain. So these are domain. This is domain of this function. So to find the domain of the function, we found the domain of each individual piece of the function. Let's look at another example of the step function. For the second example, let's continue to look at domain. So I'm going to write domain just so that we recall that we're looking at domain, not range. So for the domain, I'm going to highlight each piece this time. So I have f of x equals -3. So this is like saying y equals -3. So that's this piece right here. Notice it goes from -infinity, so it starts over here at the left, and it stops over here at an x value of -2. So this is the first piece of my function. The second piece of my function, f of x equals 0. So f of x equals 0 means y equals 0. So that's this green piece. Notice it starts at -2 and it stops at 1, and I have closed circles at both of those values. And the last piece, f of x equals 3. So I'm going to start here at y equals 3, and I'm going to go on forever to the right, because the arrow, I have a right arrow that says go forever to the right. And notice I have an open circle here at x equals 1. So domain, remember, that's your x-axis. So you're looking at how far left and how far right your graph goes. So in this graph, let's start with the yellow piece. Notice this arrow to the left means it goes forever to the left. Remember, the way that we say forever is infinity, and since it's left, it's negative infinity. And it stops over here at this open circle when x equals -2. So this is where this graph stops, is over here at x equals -2. So it goes from negative infinity all the way up to -2, and there's an open circle at -2. So these are both going to get parentheses. Then I step up, so this is still a step function. I step up to the next piece. So it starts at x equals -2, and there's a closed circle, so it's going to be a bracket, -2, and it ends at 1. So -2 all the way up to 1, and that fits a bracket. So I have an open circle here at 1. So it's open circle at 1. So I'm going to go 1, comma, and then it goes all the way to the right, and it never stops going. Remember, that arrow means it goes on forever. So I write infinity, and this is to the right, so it's plus infinity. So I'm going to write 1 to infinity like that. So I have one more example that I want you to try on your own. I will label each function for you so you know which part is which. So f of x equals 1, this is the first function. F of x equals 2, the second function is here. F of x equals 3, this is the third function. It's here. Then f of x equals 4 is the fourth function, it's here. So here's where each of those functions are located. Try to find the domain of each of those pieces of the function. So remember, it's smallest x to the largest x for the domain. So give it a try. Pause the video. When you unpause it, I'll have worked out the solution for that one. So I'm going to go through and I'm going to explain each of these pieces of the domain. So for the first one, for function number 1, it starts at -4 and ends here at -3. So I put -4, comma -3. -4 gets a bracket because it's a closed circle at -4. -3 is a parenthesis because it's an open circle at -3. Then I step up to go to function number 2. So I step up, and here I'm at function number 2. So function number 2, I start with a closed circle at -3. So those both shared -3. So this time it got a bracket because it was a closed circle, and it ends at -2. So it stops here at -2. So -3, comma -2. -2 had an open circle, so it gets a parenthesis. Then I step up to the next function. So I go up here. Here's the next piece of the function. So I start at -2. This time it gets a bracket because it's a closed circle, and I end here at -1. So I go from -2 to -1. -1 gets a parenthesis. Then I step up, and I go to this next part of the function, so the fourth part. So a closed circle at -1 this time because it's a closed circle, so I get a bracket. And then this function ends at 0. So the x value there is 0. So this is the domain of this function. So having watched this video, you should be able to complete the assignment that's in MathXL. It's called absolute value graphing.